In late spring of 2025, a Chinese startup walked into a room in Shanghai and dropped an AI model with 2.8 trillion parameters, the largest ever built in China. By lunchtime, it was being benchmarked against the best models America had. By the end of the trading day, billions of dollars had been wiped off chip stocks across Asia and the United States. Samsung, SK Hynix, NVIDIA, all of them falling. Not because anything was wrong with their products, because investors suddenly weren't sure the products mattered as much as they thought. The startup was called Kimmy. The model was K3, and almost nobody outside of China had heard of either one 6 weeks earlier. The market reaction was violent and immediate. Samsung stock dropped more than 6% in a single session. SK Hynix, which had committed over $600 billion to new chip fabrication plants, saw investors openly questioning whether that spending was justified. The logic was brutal. If a Chinese startup can build a frontier competitive model using fewer and less advanced chips, then maybe the demand for the most expensive chips in the world isn't as guaranteed as everyone assumed. Maybe the moat around American semiconductor dominance isn't as wide as the stock price suggested. That alone would be a headline. But it's not the story. The story is that this already happened, almost exactly 1 year earlier. A company called DeepSeek released a model that performed near the frontier at a fraction of the cost. Same shockwave, same market panic, same stunned headlines in Western media asking the same question. How did they do that for how little? DeepSeek's training costs were estimated at roughly $5 to $6 million. American models of similar capability were being trained for hundreds of millions. The cost gap wasn't small. It was an order of magnitude. When something like this happens once, it's a surprise. When it happens twice in the same way with the same reaction, it's not a surprise anymore. It's a pattern, and patterns demand a different kind of explanation than one-offs. A one-off can be luck. A one-off can be a stolen shortcut. A pattern is a system producing predictable results. And once you see the pattern, the real question isn't how one startup built one good model. The real question is what kind of system keeps producing these results. Because that system is what America doesn't understand. And the misunderstanding starts with a chip. In October 2022, the United States rolled out the most aggressive semiconductor export controls in decades. The logic was straightforward. Advanced AI requires advanced chips. NVIDIA's top-end GPUs were the gold standard. Cut China off from those chips, and you slowed down China's ability to train frontier AI models. Straightforward, clean, logical, except it didn't work. Not the way it was supposed to. China didn't stop. China adapted. And the adaptation happened across multiple fronts simultaneously. First, companies stockpiled. In the months between the announcement and enforcement of the restrictions, Chinese firms bought every advanced NVIDIA GPU they could get their hands on. Warehouses filled with A100S and H100S purchased through intermediaries in Singapore, Malaysia, and the Middle East. The chips America tried to restrict were already sitting in Chinese data centers before the policy took full effect. Second, domestic chip manufacturers accelerated their own development timelines on an emergency footing. Huawei's semiconductor arm, HiSilicon, pushed out AI accelerator chips that weren't as fast as NVIDIA's best, but were fast enough to train competitive models. The Ascend 910B became the workhorse of Chinese AI training. Not as elegant, not as power efficient, but functional, and available without asking Washington for permission. Third, and this is the part American planners hadn't fully accounted for, Chinese AI labs got radically better at software. When you can't get the fastest hardware, you learn to squeeze every drop of performance out of whatever hardware you have. You optimize your training code until it runs twice as efficiently. You develop model architectures that achieve comparable performance with fewer parameters. You figure out how to train on distributed clusters of older chips that American labs would have thrown in a recycling bin. You innovate at the software layer because the hardware layer is blocked. And once you've built that muscle, you don't lose it when better hardware eventually becomes available. You just get faster. The restriction was supposed to create a ceiling. Instead, it created a capability that persists even after the ceiling is removed. The export controls didn't create a wall. They created a gym. And China came out of it leaner, more efficient, and more creative about computational resources than any AI ecosystem on Earth. American labs had the luxury of throwing more hardware at every problem. Chinese labs learned to solve problems with less. Both approaches work, but only one of them scales downward. Only one of them can be exported cheaply to the 150 countries that will never have access to NVIDIA's best chips either. Jensen Huang, the CEO of NVIDIA, the company whose chips were being restricted, stood on stage at a major industry conference and showcased Chinese open-source AI models during his keynote presentation. Not American models, Chinese ones. Kimmy, Quen, models built under the very restrictions his own chips were at the center of. He featured them because they were good enough to feature. Because pretending they didn't exist would have made him look out of touch with the industry he leads. Think about that for a second. The man who builds the most advanced AI chips on the planet is demonstrating what the people who were denied those chips managed to build anyway. If the containment strategy had worked the way Washington intended, that moment doesn't happen. That slide doesn't exist. Jensen Huang doesn't stand in front of thousands of people and show off the work of the competitors his own government tried to handicap. But hardware adaptation is only the surface layer. Underneath it, there's something structural happening in China's AI ecosystem that has no equivalent in the United States. And it starts with a decision that most American companies would consider insane. China's best AI labs are giving their work away. Not all of it, not carelessly, but the volume of Chinese contributions to global open-source AI projects is enormous and growing. Kimmy's models are open-weight. DeepSeek's models are open-weight. Alibaba's Qwen series is open-weight. These aren't small side projects released for publicity. These are frontier-adjacent models with billions of parameters, published with their weights available for anyone on Earth to download, run, modify, and build on. In the American system, that's a competitive disadvantage. You built something valuable. Giving it away means someone else profits from your work. OpenAI started as an open-source research lab and then closed its models once they became commercially valuable. That trajectory, open to closed as value increases, is considered normal and rational in America's corporate framework. But in the Chinese system, the logic runs differently. The trajectory is reversed. As models get better, they get more open, not less. And the reason has almost nothing to do with corporate strategy. It has to do with how Chinese engineers relate to each other. There's a concept in Chinese professional culture built around schoolmate bonds. Tongxue, your classmates from university aren't just people you studied with. They're lifelong professional allies bound by a social contract that has no real equivalent in American corporate culture. The engineer at Baidu and the engineer at Tencent and the researcher at a startup in Shenzhen might all be former classmates from the same university cohort at Tsinghua or Peking University. They talk regularly. They share insights over dinner. They collaborate informally across company lines in ways that would trigger a legal review, a cease and desist letter, and possibly a lawsuit at most American firms. This isn't networking. Networking is transactional. Tongxue is relational. The obligations run deeper and last longer. When your former classmate publishes a research breakthrough, you don't treat it as a competitive threat. You treat it as knowledge that you're expected to build on and share back. The flow of information doesn't move at the speed of corporate communications departments. It moves at the speed of a WeChat message between old friends. Jensen Huang described this dynamic directly. He said that in China, your best engineers have their former classmates sitting in the competitor's lab across town. And when knowledge flows through personal trust networks instead of corporate legal departments, the speed of information transfer is fundamentally different. It's not faster by a percentage. It's faster by a category. Open source isn't charity in this context. It's an acceleration strategy that matches the culture. Why guard your research behind a wall when the people you're guarding it from are your college roommates' colleagues? You might as well publish it, let the global community improve it, and pull those improvements back into your next version. The innovation cycle compresses. The whole ecosystem moves faster. And the country that moves fastest across the most organizations wins. Now some American AI companies have noticed this dynamic and they don't like it. Anthropic published data in 2025 showing what they described as a large-scale campaign of distillation by Chinese companies, particularly Alibaba. Distillation means using the outputs of a larger, more powerful model to train a smaller, cheaper one. You feed questions into the big model, record its answers, and use those answers as training data for your own model. The accusation was essentially that Chinese labs were copying American models to bootstrap their own capabilities without investing the hundreds of millions of dollars in original training runs. There's some truth in that. Distillation happens. It's a real technique and Chinese labs have used it. But framing distillation as the primary explanation for China's AI competitiveness is deeply misleading. And it's self-serving in a way that's hard to ignore. If you can convince regulators and the public that Chinese models only work because they copied yours, you accomplish two things simultaneously. You discredit a competitor, and you create justification for restrictions that protect your own pricing power. That's not analysis. That's strategy dressed up as a complaint. And the hypocrisy is hard to miss. Anthropic's own AI models were trained on millions of copyrighted books, articles, and web pages created by other people. The line between learning from existing work and copying it is a lot blurrier than the accusation suggests. More importantly, multiple independent researchers, including Americans, have said plainly that Chinese labs are doing genuine original research, not just distilling, training their own models from scratch, publishing novel architectures, pushing the field forward with contributions that would be impressive from any lab in any country. One prominent AI researcher put it simply. He said their open source work, independent of any distillation, is competitive with or ahead of ours. The distillation debate is a distraction from the bigger difference. And the bigger difference isn't technical at all. It's strategic. China has a national AI deployment plan, not a vague aspiration. A mapped, sector-by-sector strategy for integrating artificial intelligence into education, logistics, manufacturing, healthcare, agriculture, military systems, and public administration. Xi Jinping has spoken about it directly and repeatedly. AI isn't being treated as one company's product or one industry's experiment. It's being treated as infrastructure, the same way electricity was treated in the 20th century. Something that goes everywhere and changes everything it touches. America has some of the most advanced AI models on the planet. What it doesn't have, according to its own national security experts, is a coherent vision for what to do with them at a national level. There's no equivalent of China's sector-by-sector deployment roadmap. There's no centralized strategy connecting the models being built in San Francisco to the school systems in Ohio, or the logistics networks in Texas, or the agricultural systems in Iowa, or the manufacturing floors in Michigan. The technology exists in extraordinary abundance. The plan for deploying it into the actual economy doesn't. The American approach to AI deployment is essentially this. Private companies will figure it out. The market will allocate the technology efficiently. Government stays out of the way, and innovation happens naturally. And that approach has produced remarkable individual achievements. GPT, Claude, Gemini, models that genuinely push the frontier of what artificial intelligence can do. But remarkable individual achievements and a national deployment strategy are two entirely different things. One produces demos. The other produces transformation. One former American defense official was asked directly on camera whether the U.S. had a vision comparable to China's for deploying AI across the economy. His answer amounted to admitting that it didn't. Not that the models were worse. That the plan was missing. That's not a technology gap. That's a leadership gap. And you can't close a leadership gap with venture capital. And while America's internal strategy is fragmented, its external strategy is actively working against itself. In the time it took Washington to argue about chip export rules, China launched a multilateral AI cooperation organization. Nearly 30 member states joined before most Americans even knew it existed. Free training programs for engineers in developing nations. Shared computing infrastructure so smaller countries can access AI capabilities they could never build alone. Technical partnerships that create long-term dependency not through coercion, but through genuine utility. When a country in Southeast Asia or Africa or South America needs AI infrastructure, the offer from China comes with training, hardware, and ongoing support. The offer from America, if it comes at all, comes with conditions and restrictions and warnings about the other offer. China isn't just building AI, it's exporting the relationship, building the kind of technology partnerships that create lasting influence. The same playbook that built China's dominance in global telecommunications infrastructure through companies like Huawei is now being applied to artificial intelligence. And it's working for the same reasons. The product is good, the price is low, and the relationship comes with fewer strings attached. And there's a fundamental difference between a country that spends its diplomatic energy pulling nations together around a shared system and a country that spends its diplomatic energy trying to keep nations away from a competitor. You cannot build an international coalition to out-cooperate China while simultaneously fighting trade wars with the allies you need in that coalition. Europe is supposed to be America's closest technology partner. In 2025, the relationship between Washington and Brussels on trade was described by multiple analysts as antagonistic. That's not a position from which you organize a coordinated AI strategy. China doesn't have that problem. Its leader flew to Shanghai and walked away with 29 new cooperation partners in a single trip. That's not luck. That's execution. But underneath the strategy and the diplomacy and the open source culture, there's a foundation that most Western analysis never reaches. And it might be the most important layer of all. Education. Chinese culture places an almost sacred emphasis on academic achievement. It's not a government program. It's a social expectation that runs generations deep. Parents push their children to excel from the earliest years. The competitive pressure of the Gaokao, China's national university entrance exam, produces a population where technical literacy isn't the exception. It's the baseline. Every year, Chinese universities graduate more STEM students than the United States and Europe combined. Not because the universities are necessarily better, because the pipeline feeding them is wider, deeper, and starts earlier. When the AI revolution arrived, China didn't need to retrain its workforce from scratch. The workforce was already trained. The talent pool was already deep. The engineers were already there, already competitive, already hungry. And critically, they were already connected to each other through those schoolmate networks that would become the invisible wiring of the entire ecosystem. This is the layer that Western analysts almost never reach. They look at the models. They look at the chips. They look at the policies. But they rarely look at the 11-year-old in Chengdu who's been doing competitive mathematics since age 7, whose parents consider anything less than academic excellence a family failure, and who will walk into a top engineering program in 6 years already fluent in the language of the systems she'll help build. That child, multiplied by millions, is the infrastructure that everything else runs on. Combine that with the schoolmate trust networks. Combine it with the open-source amplification strategy. Combine it with a national deployment plan that points every sector in the same direction. Combine it with the forced software optimization that came from hardware restrictions. What you get isn't one advantage. It's a system of advantages that reinforce each other. Each piece makes every other piece stronger. And that system is what America doesn't understand. Because America keeps looking for a single explanation. It was cheap labor. Then it was IP theft. Then it was distillation. Then it was government subsidies. Each explanation assumes China's success is borrowed or stolen or artificial. And each one misses the same thing. China built something structural. A system where culture, policy, education, and technology all push in the same direction at the same time. America has better chips. For now, America has some better models. For now, America has brilliant individual researchers and companies that are genuinely world-class. What America doesn't have is a system. It has players. China has a team. The difference between players and a team isn't talent. It's coordination. 5 brilliant individuals working in 5 different directions will lose to 5 good individuals working together toward one goal. America's AI ecosystem is a collection of competing companies guarding their research, suing each other over talent, and lobbying Washington for advantages over each other. China's AI ecosystem is a network of organizations sharing research, training each other's engineers, and deploying toward a single national objective. Both countries have extraordinary people. One country has connected them into a system. The other hasn't. And this is not about politics or picking sides. It's about seeing clearly. A country that shares knowledge through trust networks, publishes its best work as open source, maps AI deployment onto every sector of its economy, builds international coalitions around shared infrastructure, and produces a deep bench of technically literate talent from a culture that reveres education. That country is not going to be contained by restricting its access to one type of chip. The chip restriction didn't stop China. It told China exactly what America was afraid of, and China built around it. The next time a Chinese startup drops a model that shakes the market, the reaction from Washington will probably be surprise. Again, and that surprise, the inability to see it coming even though it keeps coming in the same way from the same system for the same structural reasons, is the gap that matters most. Not the technology gap, not the chip gap, not the funding gap, the comprehension gap, the failure to understand that what you're looking at isn't a series of lucky breaks. It's a machine, and the machine is running. Which part of this do you think matters most? The chip workaround? The open source culture? The national deployment plan? Or the education system underneath all of it? Tell me in the comments. Subscribe to Tech and Wired for more. No hype, no fluff, just tech that actually matters.